we're now going to open Excel. And I'm going to show you a few little tricks that we're going to do. And we have to basically add a couple of little calculators in Excel. It's going to be pretty easy, but it's basically called an analysis Toolpak. And we'll just show a couple steps on how to do that. So let's see if I can open up Excel. Let's say 2016. This will load up. I can start with a blank sheet. Actually, you know what I'll do? I'll open up the sheet that we had opened last time here. Looks like it's a sample size of subjects number 3 through 10. We must have measured from 700 to 900 milliseconds. If you're looking at my mouse cursor up on the top here, we extracted this information from electrode CP5, that is central parietal 5, which is the left parietal effect area. And it looks like we're comparing information for hits minus correct rejections. Okay? So hits is going to be bin 82. I'm even going to change that now just to make it more helpful and clear. And we'll change bin 139 to say correct rejections. Okay. And this is our subject number. Okay. So the point is that what I'm going to do here is I'm going to look in data and let's see what I can try to figure out. What we got to do is we want to add a little sucker that's going to be a little menu on the right hand side here for data analysis. Now it's not going to exist yet because we haven't yet installed it. Now it should be a quick, easy little thing, and what we got to do is search around and let's see if we can figure out how we find this. Now if my memory serves me right, we go to File and Options, and we're going to go down to this little menu here called Add-ins. Under Add-ins, we're going to grab this thing called Analysis Toolpak. Okay, and then we hit OK. And let's see here. See if that works. Ooh, maybe go. Oh, that's what it is, go. Now grab that, check the box, and hit OK. And look what happens. See how this popped up here in the top right-hand corner? And I can hover my little mouse hand over it. Can I call it a paw if it's from a mouse? No? Is it too early in the morning for those kind of jokes? Okay. So we see we got this nifty little thing called data analysis. Okay? So why don't we just press it once and it should bring up some options. So what we have here are our options for some analyses that this little toolkit now gives us. So you remember last time we just typed a little formula in and we were able to get our p-value, right? Hopefully you guys all remember that formula, or at least hopefully you jotted it down. Okay, so that'll be good to know. I think it's equals t-test parentheses, essentially your array from data set 1, your array from data set 2 that you're comparing, close parentheses, or no, I should say comma, then 2, comma 1 for two-tailed type 1, close parenthesis. So anyways, I'm sure you guys all practice memorizing that on the weekend, right? Yeah, okay, I'm just kidding. You don't have to have that memorized. Because what we're going to do here is we're going to look into a basic t-test here. And we're going to do this one here, which is t-test paired to sample for means. Right, which is nice and simple, and you're just going to hit OK. Okay, now you're going to get this little, you guys can imagine we call this a GUI, right? All right, just like in MATLAB, we learned what a GUI was. So this is a way to have a graphic user interface so that you don't have to type that long code of the formula the way that we did last class. Right? So now you can do this by hand by pointing and clicking at stuff the way that we do in MATLAB. Keep it super easy. So here's what we're going to do. Variable number 1. Okay, that's the range. We want to know that is, so let's click in this box. And then what you could do is you just select the range of the data set that you want for range 1. So in this case, we want that all the mean amplitudes of different subject numbers for the hits, the average hits, right, for each subject. And then we're going to come down in this next box here, variable to range. We're going to select the range for the second variable, which in this case, our second variable are correct rejections. So I just grab those suckers. Yeah? Okie doke. Now here's a couple little tips and tricks, okay? A couple little mini life hacks to make sure this goes okay. I like to make sure I click the button down here, the option for output options in output range. Now, when I do that, it's going to make sure it puts our results somewhere in this worksheet as opposed to in a different worksheet down here. Because I just think it's easier to have that result smack dab right next to the data that you're looking at. Okay? But when you do that, what you have to do is you need to take your mouse and click in that little this little box here. Okay? Because it doesn't naturally go there. So that's that little life hack, so to speak, for this little mini function. Make sure you click in there, and then you're going to have to tell it where do you want to put the results from this. So let's just put it, in this case, I don't know. I'll just grab this box, F2, for example, right? And that's as easy as it gets. And then you just hit OK. Boom. Now look what happened. We got a bunch of gobbledygook stuff, except it's not gobbledygook at all. We're going to look at it and see how it makes all the sense in the world. Okie doke. Now, to help, I like to stretch this out a little bit so we can read it a little bit more. Okay. All right. So, first, here we have our t-test, and it tells us what we did. It's the paired two-sample t-test for the means, for the averages between conditions. Now, our conditions were hits, and our second condition was correct rejections. So variable 1 is that first one here. So one thing you can even do is help yourself retype that in just like we did in our earlier one. So I'm just call this hits. Okay, and I'll even remind myself that it's at CP5 from 700 to 900 milliseconds. That makes life a little bit easier. And I'll type for variable 2, that's correct rejections. Okay, now let's take a closer look at what we're looking at. See this here? Our first row is the mean. That's our average. Make sense? Okay, so now we have the mean. We have the average of each of these. Now, how can we verify that? Yes, Josie?
Add up all the either or category and then divide them by all the points you added up?
Yeah, you take the average. So check this out. We'll create our own little sanity check. Because it's pretty good to make sure that you're not insane, right? I have to do it all the time. Sometimes it doesn't always check out. Okay? So let's just create in, let's say, C11 here. I'm going to call a little condition called average. And now I can come to this condition in column A, and I'll write equals average. So this is our formula. And you highlight what you want to take the average of, close your parentheses, and just press enter. Now, look at that. 2.42, and then in G5 here, 2.42. Now, if you wanted to take the average of, let's say, column B here, would you write that formula again? Why not? Okay, so you're right, it's a different column. You're going to have to readjust what you grab. But would you write any formula again? Why not? Because there's a life hack for that. Check this out. All you have to do is grab this cell here. See that little thicker corner? Grab it, hover your mouse paw. Say your mouse paw again, right? Pull that over there. And it automatically, if you double click on it, you can see that it takes the average. Isn't that nifty? Okay. And then look at this. 1.6052 excuse me, 1.605625, and that's the same as the average here. So that's our sanity check. We can know that the averages are actually accurate, right? So we've done this twice now, just so you know the computer's not messing with you, right? You're getting the right information that you asked for. So let's take a little bit of other tour through our results here. We also have our number of observations, which is our sample size. So in this case, it's 8. Okay? Oh, let's see here. Our degrees of freedom, DF, is 7, because we just talked about that earlier today, right? Degrees of freedom is your sample size minus 1. Now here's where we start getting all of our money makers, right? Our T statistic here. First of all, we want our degrees of freedom. I'm going to highlight some of this stuff that we're going to want to report. Okay? And now we see our T statistic, which is our difference between the conditions. It's 0.982. That's not our p-value. Our p-value is essentially we want the p-value for our two-tailed test. So that's there. Okay? Now, you guys see that's our p-value. That's our t-value. That's our degrees of freedom. That's our mean. And if you want to verify your standard deviation, check this out. We're going to create another thing here. So I'm going to call it ST space, or just STDEV, standard deviation. You see where I'm typing that? Boom. So we can create that too. And we're going to go, the formula for that is equals, and it's the same thing. ST for standard, and then DEV for deviation. So we're going to equals STDEV, open parentheses, and grab that same piece of information, close it, enter, and drag it across to fill in and populate that next condition. Now, one other thing that you might want to know is the standard error, which is a slightly different statistical measurement, and it's going to be really helpful as a piece of information that we're going to add to our actual bar graphs that we're going to make just a minute down the road. Okie doke. So I'm going to show you the nifty little formula we use for that. So first I'm going to define it, and I'm just going to call it SE for standard error, and I'm going to say equals. So standard error is usually calculated as the standard deviation divided by the square root, so SQRT in our formula, divided by the square root of the sample size. So to take the sample size here, you want to count how many subjects you have in this condition. So you just write count, open another parentheses, count how many there are there. You close that parentheses twice to be consistent with the order of operations that you guys might remember from your junior high algebra classes and stuff. You guys remember PEMDAS?
Please excuse my dear Aunt Sally.
What?
Please excuse my dear Aunt Sally.
Please, yeah, her too. Yeah, you guys had Aunt Sally too?
Yeah.
Hey, me too. All right, yeah, all right. Anyways, snag that sucker, drag it across. Now, why did we do that? Well, it gave us a value that we're going to add into a bar graph we're going to make. So here's what I'm trying to show you guys as we're building into it. We're going to take this information, look at all this extra stuff we got beyond that one p-value that we got finished off last class with. This is going to be that information that Nina showed us how to write a results sentence about or from. Now, when Nina wrote that elegant sentence earlier in the class, I drew a nice little bar graph next to it, didn't I? Yeah? It's helpful to visualize what the sentence is saying, right? So I'm going to show you how to do that together. Okay? So first, I'm going to even define these conditions a little bit easier by giving a label there. And what you can do is see how I highlight these 4 cells, the hits, correct rejections, and then the average for each of them respectively. Now look what I can do. I can come to our data tab, and I can, actually I'm going to go to insert tab. My brain is jumping ahead. And I'm going to grab this option here for insert a bar graph. Just take the top left one, and we get this nice graph here. Now I'm going to clean it up right from the get-go. I'm going to delete these horizontal lines because nobody likes them. They're distracting. I'm going to come to the Home tab. I'm going to bump up our font size a little bit, maybe to 16. Same thing for the x-axis. Maybe bump that up to 16. Okay, and we'll give this a title. We'll call it mean amplitudes of at CP5 from 700 to 900 milliseconds. Okay, and then we can delete, we can clean some of that up. Okay, so that looks pretty nifty, doesn't it? Nice and clean. Super easy. Okay, so let's add one more element to this called error bars. Okay, so what they're going to do is give us a little measure of what we call variance. Okay, it's really helpful to show in your graphs, and you really don't want to publish a paper without them. So I'm just going to show you how to do it. We're not going to get into any more nitty-gritty about it. All we're going to do is go to under Chart Tools. First of all, I'll click, let's say I'm out of the graph, click in the graph and then click on one of those bars, and they'll both be selected. I'm going to go to Chart Tools, Design, Add Chart Element, and I'm going to come all the way in the middle here to Error Bars. And in this option at the bottom that says More Error Bar Options, we're then going to grab this bottom little option for Custom. It's going to ask us to specify the value. We're going to snag that. And we're going to have another little GUI here. Now this is why we need to put information here and here. This is why we calculated this. And that's why I told you the formula. You don't have to memorize the formula. By the way, I'm going to upload this worksheet to Blackboard for you so you can copy those formulas and download it and work from it. You know, I'm not trying to screw you over here. I'm trying to give you the tools. Okay? And we're just going to grab these two. We're going to highlight this together, and we're going to put it there, and then we're going to highlight these together again, and we're going to put it there. And you're going to see what happens. So boom, you press the Tab key, moves it there, and there, and then you just hit OK. Whoa. So look at this. Look at these variables. Look at these error bars. Look at how big they are. Boom. Boom, there's a lot of variance. They're overlapping. That's why it's not significantly different. Right? So we have a pretty low sample size, and it's pretty messy data. We might need more than a sample size of 8, which is why I suggested a sample size of 25. Yeah? So what you guys will do is work this through. The sample is 25 for different conditions, and hopefully see that these get tinier and these get further away. And that will become significant. Now, here's the last little chunk of our lesson, right? We need to write a results summary, a little statement or two about whatever we discovered on our journey here. All right, so this is what Nina gloriously walked us through earlier in the class. Okay, so I'll show you again how we're going to do that here. I'm just going to scoot this over. I'm going to add in, just for sake today, a little text box here. Okay. Now in our text box, I'm going to increase my sample size, let's say to, I don't know, 16 or so. And you guys remember what we started off class writing about? We need to include a handful of information, most of which I've taken the liberty of highlighting for you in yellow. Right? So what we're going to say is we're going to report what we found when we assessed hits and correct rejections, particularly their mean amplitudes, right? So let's start off by that, and let's just start, for example, say average amplitudes for hits at scalp site. Whoop, let's actually bump it at left parietal scalp site. Scalp site CP5 from 700 to 900 milliseconds. So what were the average amplitudes for hits at left parietal site CP5 from 700 to 900 milliseconds? Who remembers? They're right up there. What's the number? Oh, maybe you can't see it, can you? Yeah, you can. 2.422125, right? So let's just say 2.42. So was 2.42. Now these were volts, but they were mu volts. You guys know what mu volts are? Mu? You guys know millivolts, right? They're even tinier. So there's a little trick I want to show you guys of how to add in that symbol for mu. A little Greek symbol for mu. Okay, what we'll do is we'll go to insert, I believe it's symbol. There it is, on the right hand side, symbol. And we're going to find the little symbol for mu. There it is, this one. Boom, that one, and hit insert once, and then close. See how it made this little symbol? That's your mu volt. So, average amplitudes for hits at left parietal scalp sites. I'm going to say were greater, or were larger, than correct rejections and we are going to say, now by the way, how am I saying that they're larger? I thought we said they're not significant, right? That's kind of funky. How can I get away with that? How can I get away with that?
But saying that they're not larger?
I'm saying that they are larger.
Or not significantly
Yeah.
larger? You can put that.
Yeah, exactly. So the way I can get away with it is because it's true. They are bigger. The question is, are they significantly bigger? And the answer is no. So we can say both. So we say the average hits for, or average amplitude for hits at left parietal sites, CP5 from 700 to 900 milliseconds. Oh, this is our mean, right? And we should put that in parentheses. And we want to add in our standard deviation, because that's what you guys remembered to do. And our standard deviation, we know over here is 2.56. Okay? It's 2.56. We're larger than that for correct rejection, so let's add the mean in there too. For correct rejections, that was 1.61. And the standard deviation for the correct rejections was 1.49. Okay, so now what we have is a statement. We're saying the average amplitudes for hits at this site from this time, and here's the information about them, just like Nina, remember you showed us? Okay? So we said what this is the result. What we want to know next, the second half of our sentence, is the significance of the result. So it's really easy for people to commonly confuse the difference between a result and the significance. Right? They're actually different things. That's why I said, how can I say they're bigger when we know that it's not significant? Well, because the result is still true. They are bigger. It's just that they're not significantly different in that size. So it's an important nuance and subtlety, but really important. So now, right, now we're going to actually report the result of this t-test. Now, how many of you guys are old enough to remember when we walked through what a sample t-test result might look like earlier in the class? We can all remember that? Okay, I'm old enough to remember when when we did that, all the way back in the Stone Ages about 30 minutes ago. Okay, so let's see if we can do that again. What do we start with in this sentence, or in the section reporting a t-test? Parentheses of what? Is t in the parentheses? Yeah, t, parentheses, and what's in our parentheses? Degrees of freedom. Spot on. Great job, Heather. What are our degrees of freedom? Hint, they're in yellow. Okay, 7. And will it always be 7? Why will it not always be 7? Sample size will change as you guys up that size. Okay, now we say t of 7 equals, what was our t value here? And remember, we wanted to do a two-tailed t-test. So, or what's our t-test value? Can you guys see that? Is it too small? You can't see it, or it's too small? It's a 0.98. So I think let's just keep it at 3 digits for this. So it'll be 0.982. Actually, the 2 is going to round up because there's an 8 after it. So 983. Let's type that in. 0.983, comma, right? What else do we have to add in here? P-value. Exactamundo. So p-value equaled what? 0.358. Good job. 0.358. Perfect. So let's put a period there at the end, but let's add a little something in the middle here, right? Because we actually need to bridge all of this with this. We need something right in the middle here. And what I mean by that is I'm going to type some words. So what we're going to say is average amplitudes were bigger for hits than correct rejections. Numbers, blah, 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 blah. Right? All we really want to know is hits are bigger than correct rejections. Good. But we need to add something in here that says, but by the way, this difference was not reliably significant. Or these differences were not reliable. They didn't reach significance or what have you. You follow what I'm saying? So let's add that in there. And then you'll have a nice example that'll be saved on a file that I'll upload for you of how you can add this to your reports and how we want to see our results being written up. Okie doke? Okay, so let's say, however, this difference was found to be significant. Boom. What do you guys think about that? Is that a pretty good way to summarize kind of what we did here? Yeah? So, what we've shown you today, so far in this little summary, is a handful of things, right? One, we said when you extract your values from ERP Lab using the ERP measurement tool, you will get that data put into Excel like we see here. Or at least you'll put it in a text file, you open it in Excel. And we've showed you how to get this information here by virtue of first installing your data analysis Toolpak, file, options, add-ons, right? And that added in data, it added this little tab here from which we selected a t-test that was paired to sample for means, and we grabbed the different columns of data that we wanted to compare to see if they're different. It gave us this output, one column for each of our conditions. We got the average of each of them. We got the degrees of freedom. We got our t-statistic for their respective differences. And we got the p-value for a two-tailed t-test between them. So we got all that information spit out to us. And now we've seen a way that we can translate that mathematical output into a nice graphical way of communicating that in a written report. So for those of you guys who are doing written manuscript reports about the data, this is how you would report the finding for every analysis you would do. Anytime you make a comparison or run a test, this is how you would say, generally, what the result of that was. Or for those of you guys making training videos or some sort of media production about these type of processes, this is how you would show that too. Right? Now you guys would say this and you'd be able to show people a lot faster than what I've just shown you, right? Because I stopped to explain and walk through things, right? You guys would just want to streamline it, make it a lot simpler for folks. But we've looked at the written way a manuscript would report the results of that statistical analysis, shown in yellow, from the raw data output here. Now we also looked beyond a raw data. We showed how you can create this nice little table here, right? In which we were able to verify our standard deviation, our standard error, and our average for these conditions, from which we then drew upon for creating a nice, nifty little figure here. Which is also something you would want to show someone and communicate that you've learned how to do, in case somebody else might need to know how to do this. Okay? Because if you're reporting this in a paper, it sure is nice to show an actual graphical representation of that data. And this is the way that you would do it. And we've taken a little time to walk through it, but I've tried to break it down and keep it simple. It's a really simple graph. It's a very simple way to show it. You just grab the average of each of those, and you just snag the standard error that you put on top of it. Doesn't that kind of come together? I hope that kind of comes together a little bit. So oh my goodness, it's already been a whole hour, huh? Jeez Louise. I was going to say, in the last 10 minutes we accomplished a lot. My goodness. We really just revved up and took off there, didn't we? Okay, so in the last hour we've actually covered 4 or 5 different things. Now I can see why you guys are so tired. Okay, but you guys get the idea, right? Okay, so this will be the way that you'll report your statistical findings, and also the way that you will begin to create figures, what we call publication quality figures, that are figures that are of good enough high quality levels that they can be published in a journal article of a scientific report of what you discovered from having embarked on this journey into the unconscious brain. Which is truly what you're doing, right? Now for the unconscious side, right, you might not be comparing correct rejections to hits, but maybe this column will be what you output for misses. Yeah? And maybe it won't be at CP5. Maybe it might be at frontal site FZ, mid-frontal. Or maybe it might be at PZ, if you want to look for posterior implicit memory effects. And maybe it might not be from 700 to 900. Maybe it might be from 300 to 500, or 400 to 600. But this is just the example, and by using this as a template, which I'll upload for you, you can go in and look at the formulas that we used and recreate this. Right? So this will be kind of the training wheels on the bike. And I'll just give this to you, and then you can take the training wheels off and start riding the bike. Sound pretty cool? Okay, so let's see here. Why don't I pause our little device?